SGR scheduling. Why here SJF, or you can also call as SJR. Yeah, R is nothing but shortest remaining time first. That we will explain in detail. So let us see what is shortest job first. How we'll find out that the given job is shortest. Fine. So associate with each process the length of its next CPU bus. Use these lengths to schedule the process with the shortest time. So what we'll do now, first we'll see which process has arrived at what time. Now, so based on the arrival time and the time required to complete, the CPU burst is what? So whatever the amount of time is required to complete the given process, right? So whichever the process will be completed with less time. That means what? The job which takes less time is nothing but shortest job. That I will do it first. So that is the concept of shortest job here. So I can go for two schemes again, non-preemptive and preemptive. So non-preemptive means what? I'll not postpone in between. Preemptive means what? If at all, if there is any other emergent job, I will preempt, I will postpone it. So let us discuss with an example in the next slide. First, let us understand the difference between these two with respect to SJR or SJF. So one CPU given to the process, it cannot be preempted until completes its CPU burst. That means, say for example, at 0th slot, P1 has arrived. At that point of time, no other process have arrived. So obviously, I have to start with P1. So I started with P1, and in between, you assume that P1 I will complete for some time. Say for example, 5 burst cycle it will need. So before that, say for the time slot 2, P2 has arrived, but still I am not ready to give the control to P2. I will complete P1, then only I will think of the rest. Think about the rest of the jobs. That is called as non-preemptive. While starting, I will check whichever. Say for example, if for example 2 processes have arrived at the same time, then I will think whichever requires less time, then I will go with that. So if at all if only one job has arrived, then I will start with the same process itself. So based on the arrival time and based on the amount of time required to complete the job, I will start one of the process. But once I start, I will not preempt. I will not postpone. That is done in case of non-preemptive. Coming to preemptive. Here also I will think about shortest job first only. Based on arrival time, I will start with one of the arrival time and the time required to CPU burst time required to complete the job. I start with one of the process. In between, if any other process has arrived and if that requested job requires less time than the current job. Current job is, say for example, you have 5 slots you need to complete P1 you assume. I have completed 2 slots. What is the remaining slot? Remaining slot is 3 slots. Now assume that there is one more process P2 has arrived. Then P2 will require 2 slots. So what is the remaining time of P1? Remaining time of P1 is 3 slots. So P2 required time is 2 slots. So which is having lesser time? P2 is having lesser time. Then I will go with P2. So I will postpone the P1. So anyway, I will be explaining in detail with example. So preemptive means you will postpone. Non-preemptive means you will not postpone. Both the case, when I start the process, I will check the arrival time and the time required to complete the job. Whichever the job is going to require less time, that I will be going to start first. So here, so shortest remaining time first. So I will go with the concept of shortest remaining time in between when I will preempt. So SJF is optimal. It gives minimum average time for a given set of processes. Why? In case of SCFS, you would have observed. See, in the first example, average time is 17. The second one, average time is 3. Because if you change the order, see here, average time is getting reduced. Fine. So, but whereas in case of SJF, we are trying to concentrate on the job which requires less time. So, obviously, average waiting time will be less. Waiting time will be less here compared to FCFS. So, let us see, let us understand. So, here this is an example of non-preemptive shortest job first. So, these are the process we have P1, P2, P3, P4. Then the arrival time for P1 it is, P1 has arrived at 0th second, then P2 has arrived at second, and P3 has arrived at 4 seconds, P4 has arrived at 5 seconds. And the bus times are given here. P1, it requires 7 slots to complete, P2 requires 4 slots, P3 requires 1 slot, P4 requires 4 slots. So, first let us start with 0. So, let us write the heading here, SJF, non-preemptive. So, I don't have the complete thing. First, I will start. Just you write with a 0th second. Don't complete these things. Just here one line and 2 lines, parallel lines you write off. Then, start writing from anyway. I'll start with 0th time. Which job has arrived at 0th slot? P1 has arrived at 0th slot. Is any other job has arrived at 0th slot? No. So at 0th slot, I can start only P1. So whatever the time it requires, I have to start with P1. So let us start with P1 now at 0th slot. Now let us see next process, say P2, P3, P4 at what time they have arrived. P2 has arrived at 2 seconds, P3 at 4 seconds, P4 at 5 seconds. So which has arrived first among these three? P2 has arrived at second, 2 seconds, fine. So at 2 seconds, now I should check whether I can continue with P1 or P2. But I already explained in the previous slide that in case of both these schemes, in non-preemptive, initially I will check. Before I start, definitely I will think whichever requires shortest time, I'll go with that. But once I start, I will not preempt. In case of non-preemptive. In case of preemptive, I am going to check whether I can postpone it or not. So I will not postpone here in case of non-preemptive. So I have started with P1. So I know that P2 has arrived at 2 seconds, but I don't want to preempt P1. So let me complete P1, then I'll think of other process. Okay, fine. So P1, I have continued. Even though P2 has arrived at second slot, P3 has arrived at fourth slot, P4 has arrived at fifth slot. I will not worry about this. Let me complete P1. How much time it needs? It needs 7 slots. So at the end of 7 slot, I have completed P1. Right? So this is done now. Now, before I start the rest of the jobs, let us see at 7th slot whether all my processes have arrived. The rest of the process, which are on the process remaining, P2 is remaining, P3 is remaining, P4 is remaining. So P2 I have not started with, P3 I have not started with, P4 I have not started with, P1 I have started and they have already completed. Fine. So among these three, let me check within this at the 7th slot. Before this 7th slot, at the 2nd slot only P2 has arrived, I know. And at 4th slot only P3 has arrived. At 5th slot only P4 also arrived. All these are arrived now. So I have to consider all these three processes are to be considered now. So among these three, now observe the required time here, bus time. So based on this required time, I'll decide which one I will start, whether to start with P2 or P3 or P4. So among this, P2 requires 4 slots, P4 requires 4 slots, P3 requires only 1 slot. So which requires less time now? P3 requires less time. So what is that I will do? I will do the shortest job first. So P3 I will do it first. So I start P3. So P3 you are going to start in between. See, 1 slot I need to complete my job P3. In between any other has arrived, maybe 0.5 if at all, if any other job is arrived, then I supposed to worry. No other job has arrived for another 1 slot, right? So what is that I will do? I'll complete my P3. So plus 1 bus time I need, 7 plus 1, it is 8. So at the end of the 8th slot, I have completed my P3 now. So at this time, so I know that which are all the process remaining. P2 is remaining, P4 is remaining, and both require same amount of time. Say for example, if P4 requires less time, then I would have continued with P4 itself. Since both the process require same amount of time, and now what is that I will do? Which one has arrived? P2 has arrived first. So P2 was kept in the queue first than P4. So what is that I will do? I'll continue with P2 now. So P2 is going to be continued. So how many slots I need? 4 slots I need. So I know what is that. See here in between, why I am not preempting here P2. I know that P4 also requires 4 slots, but because of non-preemptive, what is that I have done? Once I started with P1, I completed, then only I started with P3. And anyway, there was no question of preempting because there was no other job arrived between 7 and 8. Job has arrived, but no other job you can calculate in between because no 0.5, 0.75 values are given. So here, no question of preempting P3. So you have done with P3 now. So because of P2 has arrived first, I started continuing with P2 than P4. Both require same time, but still I preferred P2 because P2 has arrived at 2 seconds, which is before than P4 arrived at 5th second. So since P2 was kept in the queue first than P4, I will go with P2. Once I started with P2, I will not preempt P2, I will complete. How many slots I need? 4. 8 plus 4 is how much? 12. So at the end of 12th slot, I have completed my P2 now. Now, which is the job left out? P4 is left out. Fine. P4 is already arrived. I will continue with P4 now. How many more slots I need to complete P4? I need 4 more slots. So 12 plus 4, it is how much? 16 slots. Fine. So you have done with this. So I'll just brief before we calculate this. So how we have 4 processes. What are those? P1, P2, P3, P4. Fine. So P1 has arrived at 0 seconds. P2 has arrived at 2 seconds. P3 has arrived at 4 seconds. P4 what is it? P3 has arrived at 4 seconds and P4 has arrived at 5 seconds. And we also have to concentrate on the bus time. The amount of time required to complete P1 is 7, to complete P2 is 4, and to complete P3 is 1, and to complete P4 is 4. So initially, I will start at 0 second. Which job has arrived? P1 has arrived, and at that particular instant, no jobs have arrived. So I will start with P1. Once I start with P1, I'll not preempt, I'll not postpone. I'll complete my P1. How much time it requires? 7 slot. So at the end of 7 slot, I have done with P1 now. Now, which are the processes remaining? P2, P3, P4. So among these 3, don't worry about the arrival time first. Check about the bus time. Which requires less time? P3 requires less time. Because P2 and P4 same 4 slots it requires. Since P3 requires less time, I'll continue with P3. And once I start with P3, I'll not postpone it. So I will complete my P3. How much time it need? 1 slot. 7 plus 1. At the end of 8 slot, I have done with P3 now. Now, which are the process remaining? P2 and P4. How much time they need? 4 slot and 4 slot. Both are same. Even though both time is same, amount of time required is same for both P2 and P4. Why I am giving preference for P2? Because P2 has arrived at 2 seconds. That means what? P2 has arrived first than P4 has arrived. Correct, no? So since P2 is in the queue first, I'll go with P2 now. So I'll start with P2. How much time P2 needs here? 4 slots. So 8 plus 4, how much? 12 slots. So at the 12th slot, I have completed my P2. Which was the job remaining now? Only P4 is at the last. So P4 you are going to start now at the 12th slot. How much time it needs? 4 slots. So 12 plus 4 it is 16th slot. So at the end of the 16th slot you have completed with P4 also. So all the processes are completed between 0 to 16 slots here. Now let us calculate average waiting time now. So here when you calculate average waiting time, when I explained FCFs individually, I have taken for P1, then P2 and P3. Okay, here also you can write down the steps in between. So same, which is the order I will take? P1, 2, 3. That will be easy, that you remember. So while calculating average waiting time, I'll calculate waiting time for P1 first, then P2, then P3, then P4. So let us check for P1. What time it has arrived? 0. What time you have started with? 0 only. So 0 minus 0 is how much? 0. Then what time P2 has arrived? P2 has arrived at 2 seconds. When you have started P2, you started P2 at 8 seconds. So 8 minus 2 is how much? 6 seconds. Fine. Then for waiting time for P3 is how much? When it has arrived, P3 has arrived at 4th second. When you start P3, P3 has started at 7th slot. 7 minus 4, how much it is? 3 slots. Correct? Next, what time P4 has arrived? P4 has arrived at 5th slot. What time you have started with P4? You have started with P4 at 12th slot. So 12 minus 5 is how much? 7. So add all this, divided by how many process 4, you get the average waiting time.